So far, we've looked at our exponent rules, rational exponents, and graphing square roots. We're going to take the time now to review and get ready for our quiz. So first, we have exponent rules. Okay, remember there are different orders that you can simplify expressions with exponents. As long as you remember your rules, you'll still get to the right answer. So for the first one, 2x squared times 3x to the negative 5. Okay, what comes to mind first is that I got these two coefficients out front. Right? They do not have any exponents, so all I'm going to do is multiply them. 2 times 3, 6. Then I've got x squared times x to the negative 5th. To me, I see that I can add my exponents first. Another option would be to go ahead and move this x to the 5th to the bottom. But I'm just going to add. 2 and negative 5 is going to give me a negative 3. Now, I still can't have a negative exponent, so I'm just going to move x to the negative 3. The 6 has a positive exponent of a positive 1, so it doesn't need to move. So I'm just going to put the x on the bottom, so I'm going to end up with 6 over x cubed. For number 2, I can do several different things. First, I can simplify my x's and y's inside the parentheses, or I can distribute my negative 2 that's outside, or I can flip my fraction to go ahead and make that a positive 2. So many options. I'm going to start by simplifying the inside. First, I've got this 2, and this is a 2 over 1, which can't simplify anymore, so I'm just going to leave that with a 2 on top. Then I've got x to the 4th and x to the negative 3. So I'm going to subtract. 4 minus a negative 3 becomes 4 plus 3, which is 7, so I have x to the 7th. And then I have negative 1 minus 2. So I'm at negative 1, and I'm going even more negative, minus 2, so you get negative 3. So I've simplified that to 2x to the 7th, y to the negative 3. Well, now I've also got a negative exponent, so I'm going to go ahead and move that down. So I've got 2x to the 7th over y to the positive 3, all raised to the negative 2. Well, now I want to get rid of this negative 2, so to do that, I'm going to flip the fraction on the inside. Put the y's cubed on top and 2x to the 7th on the bottom, and that's all to a positive 2. And now I can distribute that exponent to everything, including that 2. So y cubed squared, I'm going to multiply. I'm going to get y to the 6th. 2 squared is 4. And x to the 7th squared, 7 times 2, x to the 14th. And that's as far as I can go. Again, there were so many different routes you could have taken. You could have started with the negative 2, and even when you got here, I could have just distributed the negative 2 first and then worried about my negatives. And for the last one, I have 2x to the 0, y cubed over 6x, y to the negative 4. Right? I'm going to start by looking at my coefficients. I've got 2 over 6. That's going to simplify to a 1/3. I recognize that x to the 0 is just going to cancel out and become 1. So that means my x is going to stay on the bottom. And then I've got to do subtraction with my y exponents. 3 minus a negative 4 becomes 3 plus 4. So I have y to the 7th. And that ends up being as far as I can go. I can just rewrite it without the 1 on top. Just using your exponent rules. We also talked about simplifying radicals. Remember this number that's in our little check part of the radical? That's called our index. It's a very important number. Whatever the index is what we're looking for groups of once we simplify and break down our radical. So to start with, I'm going to make a factor tree. So we've got 25 and 10, 5 and 5, 10 is 5 and 2. I've got 3 x's, 4 y's, and 2 z's. My index is a 3. This is a cube root. So I'm looking for groups of 3. So I've got 3 5's, 3 x's, 3 y's, and I can't circle the z's because there's only 2. For everything that you circle, you're going to pull 1 out. So I'm going to pull out a 5, an x, and a y. And I've still got my cube root. Under my radical, I've got this 2 that I didn't circle, a y, and 2 z's. Then I just multiply. 5 5xy. I'm going to rewrite. I can't simplify that. Then I'm going to have 2yz squared. That's as far as you can go. Remember, once you break down and once you make your factor tree branch off from a number, I no longer use that number. So I'm not going to use 25 because I broke that down into 5 times 5. Rational exponents. Okay, remember, power over root. Power over root. So for this one, I've got a negative 1/2, 36 to the negative 1/2. Well, the first thing I can do is get rid of that negative. So I'm going to make this 1 over 36 to the positive 1/2. So it's to the first power, and it's a square root. So I'm going to take the square root of 1 over 36 to the first power. Remember, a fraction, you just take the square root of the top, the square root of the bottom. The square root of 1 is 1, the square root of 36 is 6, and anything to the first power is just itself, so it's just 1/6. For number 2, I got 9 to the 5/2. My power is 5, it's raised to the 5th power, and it's a square root again. So I have the square root of 9, and I'm going to put the 5 on the outside. The square root of 9 is 3, and 3 to the 5th power is 243. And number 3, negative 8 to the 2/3. So that's the second power, the third, or cube root. So I have the cube root of negative 8 and squared. Remember, you can take an odd root of a negative, and your answer is just going to be negative. You cannot take an even root of a negative. So the cube root of negative 8 would be negative 2, and then negative 2 squared is positive 4. And finally, we have graphing square root functions. Remember, your original or your general form is a times the square root of x minus h plus k, where that point hk with opposite sign for h is our starting point. We're going to make that swimmer's arm shape. So for this one, my hk point is going to be a positive 1, positive 3, and then this 2 out front for a tells me 2 things. 1, it opens up, or it goes up like our parent function, and also it's stretched by 2, so that means it's going to be taller. So if I sketch a graph, I'm going to go to 1, 3, and then I'm going to put my dotted line for what it usually would look like if it wasn't stretched or compressed. And then my solid line is being stretched, so it's going to go above. Remember, your domain is always going to be h to infinity. So for us, it is 1 to infinity. Okay, and that's only because we're not going to reflect it over the x or the y-axis. We're never going to have it going to the left. It's always going to go to the right for us. The range, in this case, I have no y values until I get to my graph. So at 3, I have a y value, and then it's going to go up forever. So it's 3 to infinity. For number 2, my h value that's inside with the parentheses, there's nothing there, which means it's a 0. And then my k is 1. And then I've got this negative 1/3. Tells me 2 things. That it's going to go down this time, and it's compressed, so it's going to be flattened. Alright, so on my graph, I'm going to go to 0, 1, put my HK point. I know it's going to open down, so I'm going to put my dotted line going down, and it's going to be compressed, which means it's going to be flatter, so my solid line will look something like that. Your domain is always the h value to infinity for what we do, so it's 0 to infinity. And the range, in this case, is going down forever, so I'm going to start at negative infinity and stop at the k value, which is 1. Uh-oh. I don't know what happened to my graph. There it goes. Okay, and for number 3, this time I've got x plus 4 minus 2. So my h value is a negative 4. My k value is a negative 2. And now my a value is just a 1, which means it's going to open up because it's positive, but it's going to not be stretched or compressed. So I'm going to go on my graph to negative 4, negative 2, put a point. And now instead of having a dotted line and a solid line, I'm just going to have a dotted line because it's not stretched or compressed. My domain, negative 4 to positive infinity. And the range, negative 2 to positive infinity.